All right, so I wanted to go through this factoring worksheet with you if you wanted some more practice with factoring. What we're used to doing with factoring is we're used to seeing a trinomial that looks something like this, where the coefficient in front of the x squared, here it's noted by a, is 1. We look for two numbers that multiply to get to c and add to get to b. So I want to look at a couple of different types that are not like that. So first of all, let's take a look at the difference of squares. All right, so in this case, we're going to have two terms, right? We're going to have, both of them are going to be perfect squares. And it has to be a difference. It has to be an x squared minus b squared, or a squared minus b squared. This does not work if I have an a squared plus b squared. All right, so if I have an a squared minus b squared, I can rewrite it as a minus b times a plus b, or a plus b times a minus b. All right, so I'm going to look at a couple of these. So let's take a look at the first one. I have x squared minus 49. All right, the perfect square of x squared is x. The perfect square of 49 is 7. So I'm going to get an x minus 7 times an x plus 7. All right, now let's take a look at number 2. So I have a 16x to the 4th minus 81. All right, so the perfect square of 16x to the 4th is going to be 4x squared. And the perfect square of 81 is going to be 9. So I'm going to rewrite this as 4x squared minus 9, 4x squared plus 9. Now, if I look at that first part of the product, I have another difference of squares, where the perfect square of 4x squared is 2x, and the perfect square of 9 is 3. I can't do anything with 4x squared plus 9 because it has a plus sign in between instead of a negative sign in between. So it's only for differences. So this is going to become a 2x minus 3, a 2x plus 3, and then 4x squared plus 9 is going to stay the same. All right, now let's take a look at number 3. I have 121y squared minus 36x squared. 11 squared is 121, and 6 squared is 36. So the perfect square of 121y squared is going to be 11y, and the perfect square of 36x squared is going to be 6x. So this is going to factor as 11y minus 6 times 11y plus 6. All right, then lastly, let's take a look at 64x squared minus 144. Now, I think we can probably pull out a factor of 144 and 64. So let's see. I believe they're both divisible by 16. So let's factor out a 16. And I get a 4x squared when I divide 64x squared by 16. I get a 4x squared. And 144 divided by 16 is 9. All right, and this is really similar. This is exactly the same as that part of that product there, that term. But our perfect square of 4x squared is 2x, and our perfect square of 9 is 3. So this factors as 2x minus 3 and 2x plus 3. All right, so that is the difference of squares. Now we have difference in sums of cubes. All right, so in the last example, we had the difference of squares, and we could only do it if it were a difference. But with cubes, we can have a difference and a sum. I always like to think of this as if I have a difference between my cubes, that first term is going to have a difference. If it's a plus between my cubes or addition between my cubes, I'm going to have a plus. And then these two signs are opposite. This should be a plus. So I have a mistake on my page. Hopefully I will have it fixed before I get it to you. So that should be plus a b squared. All right. So let's take a look. Our first example is x cubed plus 8. So that is a sum of cubes. I'm going to have the cubed root of x cubed is x cubed. The cubed root of 8 is 2. So I have an x plus 2. Now, notice in our factor here, it's an a squared. That means my cube, what I took the cube of, I'm going to square it. So now I have an x squared. And then I have minus AB. And our A was x and our B was 2. So I have a minus 2x. And then again, my B was 2, so I'm going to square it. So I have it plus 4. Now you can always check to see if this part factors, but in this case, I don't believe it does. All right, so let's go ahead and take a look at our next example. I have a 64x cubed minus 27. Okay, so my perfect cube or my cubed root of 64 is 4, and my cubed root of 27 is 3. So we're going to use this top one because it's a difference. So I have a 4x minus 3. All right, in our case, our A is this 4x if we're looking at this formula right here, and our B is 3. So now if I have an a squared, that means I have a 4x, I have 4x squared, which is going to give me a 16x squared. And maybe I'll just write it in 2 parts, or in 2 steps. So I have a 4x squared plus a times b, so 4x times 3, plus b squared, so 3 squared. Hey, Fluss, can you get down, bud? All right, and now let's do some simplification. So I have a 4x minus 3, and 4x quantity squared is 16x squared, and 4x times 3 is 12x, and 3 squared is 9. All right, and that is it. Let's look at number 3. I believe 108 is divisible by 4, so let me put that in my calculator. Yes, so that is 27. So the first thing I'm going to do is I'm going to factor out a 4. So I have a 27 minus x cubed. All right. Again, I have a difference of squares, or a difference of cubes. My cubed root of 27 is 3. My cubed root of x cubed is x. So I get a 3 minus x. Now I have a 3 squared, which is 9, plus 3x, plus x squared. All right, and that is it on that one. Number 4, let's see. Both of them are divisible by 3. Let's see, so that's what, a 9x. Let's just go ahead with the cubed root of, yeah, let's take out a 3. Let's start by taking out a 3. So if I take out a 3, I get a 27x cubed, and I get plus 8. All right, so then the cubed root of 27x cubed is 3x, and the cubed root of 8 is 2. So I have a 3x, again, whoops, 3x plus 2. And then I have a 3x squared minus of 3x times 2 plus 2 squared. All right, so we'll simplify, and I have a 3 times a 3x plus 2, 9x squared minus 6x plus 4. All right, and the last one, I'm going to factor out a 2, and I get a 27. I keep getting 27x cubes, a 27x cubed minus 1. All right, the cubed root of 27x cubed is 3x, and the cubed root of 1 is 1. So I have a 3x minus 1 times a 9x squared plus 3x plus 1. All right, and that is factoring with differences and sums of cubes. All right, so the next one I want to look at is factoring by grouping, where we're going to group these two together and these two together. Hey, Fluffs, I need you to factoring by grouping. And usually when we do factoring by grouping, you have 4 terms. You group the first 2 terms together and the second 2 terms together. And for our purposes, when we're doing factoring by grouping so that we can do the AC method, the order in which we do the grouping does not matter. But if we introduce so many variables, then the order does matter, and we have to put it in an order that we can factor it. So let's take a look at the first 2. The first 2 just has 2 variables, so we really don't have to worry about what order we group them. So I'm just going to group the first 2 together and the second 2 together. So if I group the first 2 terms together, I want to figure out what they have in common. And what they have in common is a 5m. And when I factor out 5m from the first term, what I have left is an n. And from the second term, if I factor out a 5m, I have a 5, right? So if I went ahead and distributed this 5m to n plus 5, I would get these 2 terms back. Now what I want to do is I want to group the second or the third and fourth terms together, so my second grouping. And what they have in common is a 3n squared. When I factor out a 3n squared from 3n cubed, I have an n left. And when I factor out from a 15n squared, I have a 5 left. Now, what I'm going to look at these 2 terms is now they have a quantity of n plus 5 in common. So now I'm going to factor out the n plus 5 and then see what I have left over, right? If I have 5m times n plus 5, if I factor out the n plus 5, I have a 5m left over. And then on this second term, if I factor out the n plus 5, I have the 3n squared left over. All right, and that's the factorization of number 1. We're going to do the same thing for number 2. All right, so I have the first 2 terms, I have a 7x in common. So what I have left in the first term is a y, and the second term a 4x squared. Now, if you look at the second 2 sets of terms, so the second 2 terms, the third and fourth term, they don't have anything in common. But I'm going to group them together because they do have, if I factor out a y plus 4x squared, then I can factor that out from the first term. So I'm going to factor out my y plus 4x squared. And what I have left here is a 7x. And this one was the only thing that was there, so what I have left is a 1. Because if I multiplied 1 times 7, or y plus 4x squared, I would get y plus 4x squared back. All right, and that's that factorization. Now let's take a look at this one. Now on this one, it's going to be a little bit different because I have 3 variables. So what's going to happen is I will try to factor it the exact same way, but I will see that I won't be able to factor it, so I will just switch a couple terms around and then see what happens. So I'm looking at all of these terms, and if I look at all those terms, I have a 5m in common. So the first thing I'm going to do is I'm going to factor out a 5m. So factor out a 5m for 125m squared n. What I have left is a 5mn. From the next term, what I have left is a 6p. And from the next term, I have a negative 10m. And from the last term, I have a plus 15pn. Now, if I factor the first two together, whoops, this should be a 25. I have a mistake. Now, if I group the first two together, the first two terms, meaning the 25mn and the negative 6p, they have nothing in common, right? So I would have just one group by itself. And then the next two I would have in common, they both have a factor of 5 in common. Now, one thing I didn't say, but if I group them, the first two together and the second two together, the sign in between is what you're going to factor out. So I would factor out a negative 5 from that second set. Now, if I factored that out, what I would have here would be a 2m plus 3pn. All right, now that doesn't look like it has anything in common with those first two. So what I'm going to do is I'm going to go ahead and reorder them. All right, so why don't I reorder them so that I can factor out an m from the first two terms and a p from the second two terms. So now I have a 25p or mn minus 10m minus 6p plus 15pn. All right, so nothing changed. The only thing I did was I switched the first two terms around. All right, now because of not enough room, I'm just going to go ahead and move this up. Now if I factor out something in common with the first two terms, I have a 5n. And what do I have left? I have a 5n minus 2, right? Again, I have a negative sign in between the two sets of groupings, so I'm going to factor out a negative, and I have a negative 3p in common. And what I have left is a 2 plus 5n. Oh, forgot I factored out a negative sign. So a negative 2 minus 5n. All right, now those aren't exactly the same as 5n minus 2 and n minus 5n minus 2 and n minus 5n aren't exactly the same. So what I'm going to do is I am going to pull out a negative sign. So let's change this sign, and that sign. So now what I have is a 5n minus 2. So I'm going to skip number 4 right there so we can see this. So now I'm going to factor out the 5n minus 2. And what I have left is a 5m plus 3p. All right, so this is that correct factorization. Now, if you're not sure you did it right, again, all you have to do is multiply it out. So let's go ahead and do this one because this one was a little bit more complicated. So I'm going to FOIL. And if I FOIL, 5n times 5n gives me a 25mn. 5n times 3p gives me a plus 15 np. And negative 2 times 5m gives me a negative 10m. And negative 2 times 3p gives me a negative 6p. All right, now let's go ahead and distribute that 5m and I get 125 m squared n plus 75 mnp minus 50 m squared, and then 5n times negative 6p is going to give me a negative 30 mp. All right, now these aren't in the same order as our original problem, but we can reorder it and it'll look exactly the same. So 125 m squared n minus 50 m squared plus, minus 30 mp plus 75 mpn. All right. So then let's go on to number 4. I'm going to leave the answer up for number 3. Now, we only have one variable in this problem number 4, and this is what's going to happen on our question, most of our questions when we're thinking about factoring, is only having one variable. But if I take a look at it, it looks like I can factor out a 2 and an n. So I'm going to factor out a 2 and an n. And what I have left is a 35n cubed plus, oh, wait a minute, it looks like no, I can't factor out a 4. A 20n squared plus 28 divided by 2 is going to give me a 14n plus 8. All right, now I'm going to factor the first 2 groups, the first 2 terms, and what they have in common is a 5n squared, and what I have left is a 7n plus 4. The second 2 groups of terms, they have in common, it looks like just a 2. And if I factor out a 2 from 14n, I get a 7n plus 4. Now, each of those have a 7n plus 4 in common. So I have a 2n, we'll run out of room again. I have a 2n times 7n plus 4, 5n squared, that's what's left from here, and then a 2 is left from here. So that's the factorization of number 4. All right, and lastly, we have number 5. All right, and this one has multiple terms. Again, looks like we have 3 variables. So the first thing I'm going to do is I'm going to factor out what they all have in common. They all have a u in common, and they all have a 4 in common. So let's factor out a 4u. If I factor out a 4u from the first term, I get an 8uv. From the next term, I get a 3u squared m. From the next term, I get a 12u cubed. And from the last term, I get a 2mv. All right, and what I'm going to do, I'm going to reorder this so that I can factor out an m from the last 2 terms. So 8uv plus 12u cubed minus 3u squared minus 2mv. All right. From 8uv and 12u cubed, what I have in common is a 4u. And From 8uv, that leaves me with a 2v. And from 12u cubed, that leaves me plus a 3u squared. Right? And again, I have a negative sign in between the pairing of groupings. So I'm going to factor out a negative. Wait a minute, I'm missing something. An m right there. That's why I put them together. All right, so let's factor out a negative m. And if I factor out a negative m, I get a 3u squared plus 2v. All right, now 2v plus 3u squared is exactly the same as 3u squared plus 2v. So I'm going to factor that out, 2v plus 3u squared. And here I have a 4u left, and here I have an m left. And that's the factorization. All right, so lastly, we have come down to the AC method. All right, and this is when you have a coefficient in front of the x squared that is not 1. All right, we can't do the same thing when I have a trinomial where I multiply to get c and add to get this, right, the b term. So what we're going to do is we're going to multiply a and c. A and c coming from like our quadratic, ax squared plus bx plus c. So if you're thinking quadratic formula, the a term and the c term. So if I take a look at, well, let's see. Actually, this first one is going to be quite a bit simpler because they all have a 3 in common. So I can factor out a 3 and I get an x squared minus 3x minus 4. All right, and in this case, I need the two numbers that multiply to give me negative 4 and add to give me negative 3. All right, so that's going to be negative 4 and 1. So I have an x minus 4 and an x plus 1. Right, so these are kind of the ones that we're used to. Now let's take a look at number 2. Now, 9 is odd, so I can't divide everything by 2. So I'm going to multiply a and c. So a and c, a is 2, c is 18, negative 18. So I get a negative 36. So I want two numbers that multiply to give me 36. So multiply to give you c and add to give you b. So in this instance, at the beginning, it looks a lot like it does when we don't have a coefficient in the front. But what we have to do is we have to separate it into 4 terms. We're going to separate our b term into 2 terms. So let's see, what numbers do that? And sometimes what I like to do is I just make a tree factor, 3, 3. So let's see. 6 and a 6 is not going to work because that adds to be 9. But what about 12 and 3? I think that works. So what we're going to do, so I'm choosing negative 12 and 3. They multiply to give me 36. And they add to give me negative 9. So what I'm going to do is I'm going to split my b term into negative 12 and 3. So I have a 2x squared minus 12x plus 3x plus 18. All right. Now, notice I didn't really change the problem. All right, I just separated negative 12 and 3. Because if I add negative 12 and 3, I get my 9 back, my negative 9 back. So now what I'm going to do is I'm going to factor by grouping. And it doesn't matter if I would have put 3x minus 12x. I could have grouped them in the same way. All right, so let's look at the first 2 terms, and what they have in common is a 2x. And so I factor out a 2x and I get an x. Whoops, that should be a negative 18. I get a 2x, x minus 6. All right, the next two terms, 3x and negative 18, they have a 3 in common. And if I factor that out, I get an x minus 6. All right, so then I factor out the x minus 6, and I get a 2x plus 3. All right, and that's the factorization in number 2. Let's do the same thing for number 3. So A and C is going to give me negative 120. So I need two numbers to multiply to give me 120 and add to give me 19. So let's just start. I always like to divide by 2. So 60, 30, 15, and 5. So let's see. If I have 2, 4, 6 times 3 is 18, that's not going to work. Let's see if I have a 10 and that's not going to work. Let's see. If I did 5 times 3 times 2, that's 6 times 5, 30, no. Let's try 5 and 4 is 26, nope. 15 and 8, nope. So did I try this one? 2 times 2, 8 times 3 is 24 minus 5. That's what it is. Okay. So we're going to do a 24, positive 24, and a negative 5. So 24x minus 5x, and then the other two terms stay the same, 3x squared minus 40. The first two terms I can factor out a 3x, and I get an x plus 8. Right, I have a negative sign in between the grouping, so I'm going to factor out a negative 5, and I get an x plus 8. So I take out the x plus 8, and what I have left is a 3x minus 5. All right, the next one, number 4, I have a 5 in common in all of them. So I'm going to start by factoring out a 5, because if I look at AC, look how large that number is. It's 10 times 125, so we have like 1,250. So I get a 2x squared minus 5x minus 25. All right, still going to be pretty large, but not as bad. So my A is 2, my C is 25. So I get a 50. And I believe I need two numbers to add to be negative 5 and multiply to be 50. So 10 and 5. And I need the 10 to be negative, so 2x squared minus 10x plus 5x minus 25. I'm going to write this one down here. From the first two, I'm going to factor out a 2x, and I get an x minus 5. The second two sets, the second grouping, I'm going to factor out a 5, and I get an x minus 5. So then when I factor out the x minus 5, I get a 2x plus 5. All right, and our very last one, number 5. I have a 6 times 2, which is a negative 12. I need two numbers to multiply to be negative 12 and add to be negative 1. So that's going to be a negative 4 and a positive 3. right? In the first two terms, I have a 2x in common. If I factor that out, I get a 3x minus 2. And then 3x minus 2 doesn't have anything in common for your third and fourth terms, but I'm going to factor out the 3x minus 2, and I get a 2x plus 1. All right, so that is the factoring worksheet. Mostly, I'm concerned that you know how to factor when I have a number in A, or the coefficient for the A term that is not 1. If you have any questions, please come see me in my office hours, and have a good day. Whoops.